Hello everyone. Today we are looking at an important FE exam question from structures. A 30 kip concentrated load traverses on the following truss. Ignoring the truss's own weight, the maximum force in kips in member CD resulting from the shifting load is estimated to be. We have four options here. So this 30 kips is the concentrated load they're talking about. Let's call it P. Now the truss is simple supported truss with pin at one side and a roller at the other side. As this concentrated load travels across the truss, the reaction forces at A and B are gonna keep changing. Now in the question they want us to find the maximum force in the member CD. So if you imagine a rope, in order to create maximum force in the rope, it only happens when you apply the concentrated load at the point where you want to create maximum force. Maximum bending, maximum force, all of it happens when you apply the load directly at the point where you create it. Okay, for example, if I put the concentrated load at A, that won't create maximum force at C. Got it? Let me explain to you this same concept on the diagram over here. So this you see over here is the same simple supported truss, but with more added detail. So as this concentrated load reaches the point CD, it creates the maximum bending moment at the point C. Okay, and that is the exact scenario where you will be able to calculate the maximum force FCD. Now this formula is not available in your FE reference manual. F through the method of sections will be equal to bending moment by height of the truss. Now I'm using the word method of sections here because there is less than 3 unknowns when I make a cut in this truss. So below CD we have two other members, so together there are no more than 3 unknown forces in this truss. Our main focus is CD, so don't even bother about the other joint. So as far as CD goes, FCD can be calculated by bending moment by height of the truss. And how are you going to find the maximum bending moment? Maximum bending moment can be found by this formula. M is equal to RA times X. X is nothing but the distance of the method of section, the section from the point B. Okay, if from B this section is at X, then from A this section is going to be L minus X. As simple as that. Now this equation still needs us to find the reaction force RA, which can be found RA is equal to the point load times the distance from the section to A divided by length of the section. Very easy, like here to here is L minus X divided by length of the section multiplied by point load, that gives us the reaction at A. Okay, in this particular case L minus X will be equal to X, because when you do method of section over here, so though this looks little bit to the side, it will actually go through the center of this whole truss. Okay, so that means L minus X will be at the midpoint over here. That will be 1, 2, 3 sections. So if 6 sections are 120, 3 sections are going to be 60 feet. So P times 60 divided by 120, P is 30. So 30 times 60 divided by 120 is nothing but 15 kips. Same, if you substitute all the values, you will get 15 kips for reaction at B as well. So that way you will be able to find the reaction force, and through reaction force maximum bending moment, and through maximum bending moment the maximum force at CD. That's how you solve this problem. So let's get down to substituting and talking about all the important stuff. Okay, so please remember these formulas. I would suggest you to actually write these formulas on a cheat sheet and revise it from time to time, because these formulas are not available in your FE reference manual, but they're very, very important. So over here I'm talking about substituting all the numbers I have previously spoken. So you'll be able to find reaction at A, reaction at B, which is both 15 kips. I already told you how these numbers came. Once you find these reactions, you will be able to find the maximum bending moment at C. MC is equal to reaction at A times the span X, which is nothing but 15 times 60. So maximum bending moment is 900 Gibbs feet. Now that you found the maximum bending moment, all you got to do is calculate the maximum force in member CD, which is nothing but maximum bending moment divided by the height of the truss. Height of the truss is 12 feet and maximum bending moment is 900 Gibbs feet. So feet cancel, the unit is going to be Gibbs. 900 by 12 is 75. So FCD is going to be 75 Gibbs. Now when you're doing method of sections, a simple truss like this is acting like a beam. So when a force is acting on top of the beam at the center, it creates compression on the top and tension in the bottom. The same is happening in the truss over here. Since we're calculating the force FCD, which is the top chord of this truss, this force is a compressive force because on the beam, the top force is compression, the bottom is tension. So FCD is compression. So 75 Gibbs is a compressive force. Okay, if you look at the options, that's going to be option D. That's the right option.